Hi class. So this video is going to be over section 3.1 titled Introduction to Equations. So this is the first section in a new chapter, chapter 3, where we're going to be looking at solving equations and inequalities. So our very first objective here is to determine whether a given number is a solution of an equation. Right? So before we try an example with that, I want to go over what an equation is and how that's different than an expression, which we've talked about already. And then next, I want to go over, what's a solution of an equation. So remember, expression, right, can be numerical or a variable expression, right? We've already went over that in the previous material. So remember, a numerical expression or a constant. A numerical expression is just a constant, right? Where so there's no variable; it's just a number. Where a variable expression has a variable in there, and it varies, right, depending on the value that the variable takes on, right? So an expression is a mathematical statement with a combination of numbers, variables, and operations. Right? Where a equation, right, is always in the form of an expression equals an expression. Right? So an equation is showing where two expressions are equivalent or equal to each other. Right? So in an expression, something important to note is that there is no equal sign. Where in an equation, there is an equal sign. Right? And when talking about expressions, what we do with expressions is we simplify expressions. Right? So, like if I have, 2 times x plus 3, right? This is an expression. It's a combination of numbers, variables, and operations, right? And there's no equal sign. So this is an example of an expression. So we can simplify this expression by distributing the 2 through, right? By using the distributive property. So this would give me, 2x plus, and then 2 times 3 is 6, right? So this is the simplified form of the expression 2 times x plus 3, right? So this process is simplifying, right? So we're just, trying to write this in a simpler way, right? Where with an equation, we actually solve, right? So we simplify expressions, but we solve equations. Right? So an example of an equation is, let's say, x plus 3 equals 4, right? So we're going to go through some processes and some theorems that allow us to be able to solve an equation. But if you think through this, x is a placeholder number. What number plus 3 gives you 4, right? Well, you should recognize, 1 plus 3 is what gives me 4. So In other words, I can solve this equation and get x equals 1, right? Would be the solution for that equation, right? Because if I plug in 1 in for x, I get 1 plus 3, which equals 4, which I find, I can find that solution, right? So if I don't have an equal sign, I can't solve, right? So that's something that some people get confused, right? With 2 times x plus 3, I can't figure out what x is, right? There has to be an equal sign in order for me to figure that out, right? So now what I want to go over is the solution of an equation. So if I have, let's say, the equation x plus 8 equals 13, if I want to know if x equals 5 is a solution, I would plug in x equals 5, right, into the equation. So in other words, every place I see an x, I'm going to substitute 5 in its place, right? So I'm evaluating the equation at 5, right? So if I plug that in, I would get 5 plus 8 equals 13, right? And so what I'm doing is I don't actually know if these two things are equal. I'm testing if they're equal. So the common notation is to put a question mark above the equal sign, right? Meaning I'm not sure if they're actually equal. So 5 plus 8 is in fact 13, right? So on the left-hand side we get 13, and on the right-hand side we get 13, which this is a true statement, right? So I'll put a check mark here to show that that's true. So this is a true statement. So in other words, this is a solution. Right? Right? And I just mentioned something, some terminology. I want to make sure that you know, and that's what I mean by left-hand side and right-hand side of the equation. So let me change the color here, maybe to green. So if I have the equation x plus 8 equals 13, this side on the left is known as the left-hand side, and this side on the right of the equal sign is known as the right-hand side, right, of the equation. So it's just telling you, what side, what side of the equal sign are we on? Are we talking about, right? And I'll use LHS and RHS to denote left-hand side and right-hand side in my notation, right? If I ever refer to that. So that's just making sure I'm being explicit about what I mean exactly by left hand and right hand side. Right? So let's try another one, right? So if I have the equation x plus 8 equals 13, let's say I want to see if x equals 7 is a solution to this equation, right? What I would do is same thing. I'm going to replace the x with the 7, and I'm going to put an equal sign above, or a question mark above the equal sign, because I'm testing if they're equal. And 7 plus 8 gives me 15, right? So I have 13 on the right-hand side and 15 on the left-hand side. These are not equal, right? These are not equal. In other words, I get a false statement, which means it's not a solution, right? So you might be wondering, what is a solution of an equation, right? So I can write this up, right? So a solution of an equation is a number that, when substituted for the variable, results in a true equation. Right, so that's what a solution is, right? So, in other words, the solution is a value where if I plug it in the equation, then I get a true statement, right? Something that is true. So, example 1 and 2 have us practicing this, right? So example 1 says, is -3 a solution of the equation 4x plus 16 equals x squared minus 5? Right, so every place that I see an x, I'm going to plug in -3, right? In other words, we're saying, let x equal -3, and I want to know if I get a true statement or not. So this would be 4 times -3 plus 16 equals -3 squared minus 5. So 4 times -3 is -12. We get plus 16 equals. And so I still have the full order of operations here, right? So on the left-hand side, multiplying came before adding. And on the right-hand side, we need to square before we subtract, right? So -3 squared is 9, so I'd have 9 minus 5. So I'm just doing one operation at a time on either side. On the left-hand side, I have just one operation. So -12 plus 16 is positive 4. And on the right-hand side, 9 minus 5 is 4, right? So this is in fact true. So we could say, yes, x equals -3 is a solution, right? And if we wanted to be more correct, I could put a question mark above those equal signs showing that I'm testing the equality. I don't have to put one on the last statement because they are in fact equal, right? So I know that 4 does equal 4. So I don't need the question mark to, mean I'm not quite sure, right? A lot of times people don't write the question mark, but it's just to help you remember that we're not sure if they're equal or not, right at that point. So example 2 is very similar. It says, is -4 a solution of the equation 4 plus 5x equals x squared minus 2x, right? I just want to point out that I'm using the variable x a lot, but this would be the same process if it was like an f instead of x, or a g, or any other letter that you wish. So we're going to let x equal -4. I'm going to plug this in. So I would have 4 plus 5 times -4 equals -4 squared minus 2 times -4. And then I just need to simplify using order of operations. So on the left-hand side, I would multiply first. So we'd have 4 plus, so 5 times -4 is -20. And then on the right-hand side, I would want to square. Follow my exponent, so -4 squared is 16. Then I would have, minus 2 times -4. On the left-hand side, we could do 4 plus -20, which is -16. And then on the right-hand side, what I'd want to do next is multiply, right? So I would have 16 minus, -8. So 2 times -4 is -8. And then 16 minus a -8 is the same thing as 16 plus 8, right? So we could turn both of those to positive, right, to show that. It would be plus 8. So this would be -16 equals, so 16 plus 8 is what? 24. And these are not equal, right? So we would say, no, x equals -4 is not a solution. right? And if I wanted to, I could spell this out a little more. I could say for the equation 4 plus 5x equals x squared minus 2x, right? Just to be a little more explicit, but not necessary, right? Um, and notice I didn't put the question mark above the equal sign, but we could add that in as before. Right. So now what we have left in this section is giving you some tools, some properties, so then we can actually begin to solve equations. So the first property we're going to look at is addition. So we want to look at equations in the form x plus a equals b, right? Or in other words, a and b are constants, right? So in other words, you're going to have like x plus some number equals some number, and how do we solve this type of equation, right? And so when we solve an equation, I have a statement here. When we solve an equation, that means to find all values for the variable that make a true equation, right? The goal is for us to get the form of variable equals a constant, in other words, x equals some number, right? So if I can get, my variable equals some number, then I've found the solution, right? So in order to work with things in this work with equations in this format, we're going to need to use what's called the addition property of equations, or sometimes called the addition property of equality, right? And basically, what this property says is that I can add the same number or the same variable term to both sides, and that doesn't change the solution of equation, right? In other words, it allows us, right, to be able to add the same thing to both sides, right? So I kind of think of this as kind of like a game, and this is just one rule of the game, right? So, the idea of winning is finding the solution, but we can add the same thing to both sides, and we won't change the solution of an equation, right? And we don't want to change the solution of equation because the solution is what we're trying to get to. It's just hidden, right? So we don't want to change. We don't want to do something that changes along the way because then we're not finding out what the solution is, right? So I have something written here. It says, what do we mean by without changing the solution of the equation, right? So what do I mean by that statement, right? So let me go through a exercise and just explain that a little bit. So let's say 4 plus 3 equals 7, right? That's just a known fact, right? So if I add 6 to the left-hand side and 5 to the right-hand side, would this be equal, right? So, of course, you might be thinking, well, of course it can't be equal, right? Because really I have 7, 4 plus 3 I could replace with 7. So I have 7 on both sides. If I add 6 to one side and 5 to the other, then surely, I'm going to get different answers on either side, right? And that's true, right? So, 4 plus 3 plus 6 gives me 13, and 7 plus 5 gives me 12, and these are not equal, right? So it's just a little exercise using arithmetic. Now let's apply this, concept to an equation. So instead of writing 4, I'm going to write x, right? So x plus 3 equals 7, right? So in other words, I know that my solution is x equals 4. And I know that because of this statement here, 4 plus 3 equals 7. I just replaced the 4 with an x, right? So originally it was known and now it's unknown, but I know what it is because I made that statement, right? Of course, if I plug 4 in for x, it's going to give me a true statement. So if I take x plus 3 and add 6 to the left-hand side and add 5 to the right-hand side, right? And then I simplify, right? So on the left-hand side, I can combine the 3 with the 6. Those are like terms. So this would be x plus 9 equals, and then 7 plus 5 is 12, right? So now let's think through, what number plus 9 gives me 12, right? So if we think about this a moment, it's 3, right? So in other words, the solution now is x equals 3, since 3 plus 9 is what gives me 12, what equals 12, right? So I started with a solution of 4, but because I didn't apply the addition property of equations correctly, notice I ended up changing the solution. So from 4 now to 3, right? So that's what we mean by changing the solution of an equation. So if I would have added the same thing to both sides, then I wouldn't have changed that solution, right? So a lot of people think about, maybe explain this as a double beam balance, right, with a fulcrum, right? Or think of like a teeter-totter, right, keeping it balanced. If I have the same weight on both sides, then this balance is level, right? It's equal. So if I have 10 pounds over here and 10 pounds over here, right, like on a teeter-totter, right, if it's the fulcrum's right in the middle, it will be balanced. Right. So the idea is we want to keep the equation balanced. So what I do to one side, I need to do to the other side. Right. The exact same thing. Right. So let's practice this idea to solve equations. Right. So example 3, I'm asked to solve and check y minus 6 equals 9. Right. So, the goal in this case is I want to get y equals some number, right? Or in other words, 1y equals some number, because that's the same thing as y equals a number, right? That's the goal, is to get it in this format. I want to know what y equals. So if I have y minus 6 equals 9, how I can get y by itself is I can add 6 to both sides, right? So this is the inverse property of addition. If I add the opposite, I'm going to end up getting 0, right? So in other words, on the left-hand side, I would get y plus 0 equals, and then 9 plus 6 equals 15, right? Well, the addition property of 0 tells me, right, a number plus 0 is just that number. So this would just end up being y equals 15. So this is the solution of the equation, right? Notice we are also asked to check this, right? So if I check this, I'm just going to plug in y equals 15 into the equation. So I would have 15 minus 6 equals 9, right? So 15 minus 6 is in fact 9, and this is a true statement, so it works out, right? And so something else I want to point out here is that as long as I'm following this rule of adding the same thing to both sides, I can still come up with the answer. I might just be going about it a longer way, which is okay because we still get there, right? So the way I typically explain it, if I was wanting to drive from Marion to Cincinnati, I wouldn't, normally first go to Toledo and then drive down to Cincinnati, right? Normally I would just drive just straight from Marion to Cincinnati. But if I drove from Marion to Toledo and then from Toledo to Cincinnati, I would still get there. It just became a longer way, right? So, and that's the same thing with the solving of equation idea, right? I can still get to the same endpoint, just depending on my route. I may be, going, going a longer route to get there, right? So an example of this is if, we have the equation y minus 6 equals 9 still. If someone, just decided, I want to add 10 to both sides, right? That's perfectly fine. I can add 10 to both sides. By adding 10 to both sides, on the left-hand side, I would have y plus 4, right? Because negative 6 plus 10 is positive 4. Then on the right-hand side, I would have 9 plus 10, which is 19, right? And then so, you could add another number to this. You could keep adding different numbers, but the number that's going to help me out here is by adding, or in other words, subtracting negative 4 from both sides. Because subtracting 4 from both sides, or adding negative 4 to both sides, is what's going to get me to have y by itself, just have y on one side of the equation. So then 19 minus 4 is 15, right? So notice I'm getting the same solution, right? And that's because I added the same thing to both sides here and also here, right? So that's what preserves us keeping the same solution, right? So example 4, we have 1/2 equals x plus 2/3, right? So 1/2 equals x plus 2/3. So what I want to do is, in this case, I would subtract 2/3 from both sides, and this would leave me with x on the right-hand side, and then on the left-hand side, I'm just going to have just some number, right? So if I want to subtract 1/2 minus 2/3, I need to get common denominators. So the easiest one is to get 6, right? So if I multiply 1/2 times 3 over 3 and 2/3 times 2 over 2, I'll get a common denominator of 6. So that would give me, so 1 times 3 is 3, 2 times 3 is 6, and then 2 times 2 is 4, 3 times 2 is 6. So I get 3/6 minus 4/6, which is, so we'd have 3 minus 4 all over 6, which is negative 1/6. So this would be negative 1/6 as my solution. Right? So the next objective is to solve an equation of the form ax equals b. Right? So in other words, I have a number times x equals b. So in order to solve this, I need to use the multiplication property of equations, right? Which just tells me, similar to the addition property, that I can multiply both sides by the, by the same number without changing the solution of the equation, right? And notice it says the same non-zero number, right? So I don't want to multiply both sides times 0. And that's actually a question I have here, is why can't we multiply both sides times 0, right? So let's think through that. So what if I have the equation 2x equals 10, right? Well, my solution is going to be 5, right? X equals 5, and that's since 2 times 5 is what gives me 10, right? So 2 times 5 gives me 10, so 2x equals 10, x would have to equal 5, right? That's pretty, intuitive. But if I start with this equation, 2x equals 10, and I multiply both sides times 0, what I'm going to get on the left-hand side is 0, and 10 times 0 is 0, right? So both sides are 0 because of the multiplication property of 0, right? 0 times, anything is just 0 back, right? So this isn't really helpful, right? It doesn't help me find a solution. So it doesn't make my equation still hold true and have the same solution. That doesn't work, right? So we can't multiply both sides times 0, right? So now I just have three examples left here. So example 5, we look at solving 3x over 4 equals -9, right? So hopefully you can rewrite this as 3/4 x equals -9, right? So in other words, 3x over 4 is the same thing as 3/4 times x over 1, right? So, if we start with this right-hand side and multiply straight across, we're going to get 3x over 4. So you like doing the multiplication of fractions in reverse. So that way you can more easily see that the coefficient is 3/4, right? So I have 3/4 x equals -9. So it just makes it a little easier to work with and solve, right? Because if I have the coefficient, isolated, then I can more easily get x by itself, right? So if I have 3/4 times x, what we're going to do is divide by the coefficient to both sides, right? So division is just multiplying by the reciprocal, right? So if I multiply both sides by 4/3, right, what's going to happen is on the left-hand side, I'm left with just x. And on the right-hand side, I have -9 over 1 times 4/3, right? So if I multiply this through, negative times 4 is -36 over 3, which -36 divided by 3 is what? -12, right? So in other words, x equals -12. Right, so that's the solution for that equation. The next one I have here is example 6. It says solve and check 4x equals 6. So I have 4x equals 6. Right? So what I want to do is, since it's 4 times x, I'm like doing the opposite, right? So adding, subtracting, or like opposite operations, and or inverse operations, and multiplying and dividing are like inverse operations, right? So if I have 4 times x, in order to get rid of the 4, I need to divide both sides by 4, right? Because 4x divided by 4 is just 1, right? So this would give me x equals, and then 6 divided by 4 is, we could write that as 3/2, right? Or in other words, 1.5, right? Either way. And notice this symbol here. This is just a arrow that goes back and forth. And what that means in mathematics is that this statement here is equivalent to this statement here, right? In other words, I can go back and forth and they mean the same thing, right? So I used that earlier in the video, but just pointing out, I just realized you might not be familiar with that symbol or what that means, but that's what that means, right? So in order to check this, I just need to plug in 3/2 in for x. So 4 times 3/2, or 4 times 1.5 if you prefer that. We want to know, does that equal 6? So 4 times 3/2 would give me, so if I make this 4 over 1, that would give me 12 over 2. Does that equal 6? So 12 divided by 2 is in fact 6. So I get 6 equals 6, which is a true statement, right? So it works out, right? So now for the last example, which is example 7, I have 5x minus 9x equals 12, right? So the very first thing I can do here is simplify the left-hand side. So I haven't had to do this simplification yet, but we're going to do this a lot in the next lesson as well. So before we apply the multiplication property of equality and the addition property of equality, we first, may want to just simplify both sides of the equation to make it easier on ourselves. So the left-hand side, I have 5x minus 9x. I can simplify that to be -4x equals 12. right? So the operation in between -4 and x is multiply. So I could divide both sides by -4, and I get x equals -3, right? Because 12 divided by -4 is -3. So that's the solution. All right, so that's all I have for this section. Let me know if you have any questions. Thanks.